Hey guys, in this video we are going to be working on deciding whether or not tables, graphs, and real-world scenarios represent linear or exponential functions. And then we're going to be working with tables to write exponential functions and also real-world scenarios to write exponential functions. So if I look at the top section here, I'm given 3 tables, and my job is to decide whether they are linear, exponential, or neither. If they are linear or exponential, we're going to go ahead and write the function for that table. So let's take a look. This one here, if I'm going to decide if it's exponential, remember I need to multiply 49 by something to get 72. The easiest way to do that is to work in reverse. So 72 divided by 49 is not a whole number. So chances are when you get something like this, it's not going to be exponential. So let's work the other way. 72 minus 49 is 23. So is 72 plus 23 going to give me 95? It does. So that means I am adding 23 each time. Since I am adding 23 each time, that makes this a linear table, and it's going to be in the form y equals mx plus b. So y equals, my slope is 23, x plus my starting value, which is 49. Okay, let's take a look at the next one. 8 times a fraction or a decimal will give me 13. So I'm going to assume that this is not exponential. Now 8 plus 5 here will give me 13. Does 13 plus 5 give me 21? The answer is no. 13 plus 5 is 18. So I'm actually adding 8 here. So that means I don't have something constant here. So this is neither. All right, take a look at the last one. I know that 4 times 3 gives me 12. So times 3. And I also know that 12 times 3 gives me 36. That means this one is exponential, and that's y equals a times b to the x. So y equals, my starting value is 4, and in parentheses, I'm going to put my constant multiplier, which is 3 to the x power. All right, now the next section here, we need to classify each graph as linear, exponential, or neither. Remember, linear is going to be a straight line. It could increase or it could decrease, or it could be undefined, of course, and it could not. It could be 0 as well for the slope. A exponential graph is kind of like a curve, and if it's neither of those two things, then the answer is neither. All right, so if I'm looking at this first one, it's curving. Do you see how it increases as we go to the right, and it gets really, really close to that x-axis, but never touches it? That is definitely exponential. The middle one here is a straight line. That means it's linear. And this one here, it curves, but not like an exponential does. This one is like decreasing here, and then suddenly it increases on this side. Technically, the whole thing is increasing, but we will talk about that at a later date. This is what's called a quadratic function. So this one is neither linear nor exponential. All right, let's do the same thing for some real-world scenarios. It says an art museum starts or opens with 25 pieces of art and plans to add 6 new pieces of art each year. That word add tips me off that this is a linear function. So it's y equals mx plus b. So y equals, the slope is 6 because that's what they're adding each year. So 6x plus what they started with, which was 25. So y equals 6x plus 25. Next one says you start your collection with 10 coins and you plan to double the size of your collection each year. Doubling is multiplying. So that means this one's exponential, and it's y equals, my starting value was 10, and I'm doubling each time, so that's times 2 to the x. Last one here, you put $400 into a savings account that has a 3.5% interest rate. Now, interest rates are always exponential, so if I'm dealing with any kind of interest rate, it's automatically exponential, okay? So this one is a little bit different than the last one. So it's y equals, 400 was my starting value. Now, I know that I get 3.5% for my interest rate tacked on to what is in there, okay? So when I'm doing this, I know that this is increasing. So I'm going to do 1 plus 3.5%. So when I do that, I need to make sure that 3.5% is a decimal first. The easiest way to do that is move the decimal 2 spots to the left to get 0.035. But if that's a little confusing, you can also take 3.5 and divide it by 100. Because I'm trying to find the percent as a decimal. And then I'm going to add that to 1 because it's increasing. So it's 1.035 to the x. And that's my exponential function. Now, if it were decreasing, I would do 1 minus that amount And that's the number that would go in the parentheses. Let's talk about that down here at the bottom. All right, so I know that these are exponential tables because it tells me that they are. It says use the table to write the exponential function. Fill out the table and find the percent of increase or decrease. You can write in any of these forms. Now, the easiest one will probably be this one, but we'll work through it together. Now, since I know that these are exponential, that means I am multiplying by a constant multiplier as I go down the table, which means if I go in reverse, I'd be dividing. So that's how I'm going to find my constant multiplier. So I'm going to take any two, I'm just going to choose these two here, and I'm going to take the one that's lower, and what I mean by lower is the one that's lower in the table, and divide it by the one above it. So 153.6 divided by 192. So my constant multiplier is 0.8. So that means as I go down the table, I am multiplying by 0.8 each time. Now, I have to figure out what my starting value is before I can write my equation, okay? So I am going to keep dividing by 0.8 until I find that value. So 192 divided by 0.8 is 240. And divide that by 0.8 to get 300. So my starting value is 300, making my equation y equals 300 times 0.8 to the x. And I can keep multiplying by 0.8 to find the last two. So 122.88 times 0.8 is 98.304. And multiply that by 0.8 again, and I get 78.6432. All right, so here's the tricky part. First of all, if I'm looking at this table, you should notice that the numbers are going down. So that means it's a decrease. Now, there's a 0.8 in the parentheses here. When I talked about this problem right here, number 9, I told you that you were either going to have to do 1 plus the percent or 1 minus the percent. And if it was decreasing, you needed to do minus. So that's what we need to do here in order to find my percent decrease. I need to do 1 minus this number right here. 1 minus 0.8 is going to be 0.2, meaning that my percent decrease is 20%. Okay? So again, here's how I got that. I am using 1 minus my constant multiplier, which is r. Okay? And I know that that is going to be equal to, well, if I plug it in here, I'm going to have 1 minus 0.8, which is equal to 0.2, which as a percent is 20%. Okay, so 20% is my percent of decrease. Let's do the same thing with number 11. This one here, you should notice that it's increasing, so it's going to be a percent increase. Okay, now let's figure out what that increase is. So I'm going to do the same thing. Take two of the numbers, take the bottom one and divide by the top. So 650 divided by 250 is 2.6. So that means I should be multiplying by 2.6 each time. And let's just double check. So 650 times 2.6 is 1690. So I know that that is the correct multiplier. So if I keep going down, I get the 43, and then I'm going to get 11,424.4. Now to go up the table, I'm going to do the opposite. I'm going to divide. So 250 divided by 2.6 is 96.1538 ... Okay? And then the same thing, I'm going to divide by 2.6, and I'm going to get 36.9822, and then ... is fine. Now I know that my starting value is 250, so it's y equals 250, and in parentheses, I'm going to put my constant multiplier, which is 2.6, to the x. Okay? Now, since it's an increase, I know that it's got to be 1 plus r. Okay? Now, my rate is 2.6 here. So I know that 1 plus my rate has got to be equal to 2.6. This is actually how I should be doing it here. And to solve this, all I need to do is subtract 1 on both sides. And I get r equals 1.6, which is actually 160%. So my percent of increase is 160%. When my number inside the parentheses here is bigger than 1 point something, that means that your percent is going to be over 100%. Okay, so how I actually should have done this one is more like this if you want to stay consistent. Equals 0.8. I would subtract 1 Let me show you how to do it over here, just in case you want to be consistent. So I'd subtract the 1, and I get negative r equals negative 0.2. Divide by the negative 1, and I get r equals 0.2, which is the same as 20%. So staying consistent might be a good idea there. All right, let's talk about some real world scenarios. All right, it says Leslie buys $500 worth of clothes with her credit card. The balance then grows by 8.6% interest each month. Write an exponential equation to show the balance on Leslie's credit card given the number of months, which is X, okay? So I know that this is my starting value, so this is my A. And I know that this is going to be it's part of my constant multiplier. So this is a growth here. So it's going to be 1 plus 0.086 because I need to change that to a decimal. So in my equation, it's going to be y equals, my A is 500. The 1 represents the balance itself, and then I'm just adding on the 8.6%. So I have to change 8.6 to a decimal, which is that 0.086. And then it's to the x, where x represents the number of months, okay? So you can either leave the equation like this, which is the same, or you could rewrite it if you want. It's the same as y equals 500 times 1.086 to the x. I will take either equation. Then when you get down here, it wants to know what is the balance on Leslie's credit card in 6 months. So I'm going to take this 6 and plug it in for x because x represents months. So I have y equals 500 times 1.086 to the 6th. And then I'm going to take my calculator and figure that out. So 500 times 1.086 to the 6th, and I get $820.26. Yes, they will round up on that credit card. So I'm going to get $820.26. That's how much money will now be on that card after 6 months, which is why it's so important to pay those credit cards down as much as you can. All right, same thing here. The exponential equation y equals 4,000 times 1 plus 0.075 to the x models the amount of money in Sharon's savings account that earns annual interest. First question wants to know, is Sharon's balance increasing or decreasing? The way to tell is by looking at this sign right here. Since it is a plus, this is increasing. If it were minus there, it would be decreasing. Then it says, explain the real world meaning of 4,000. Well, remember, this spot here is for your starting value. So you want to say that Sharon starts with $4,000 in her account. Then it says, explain the real world meaning of 0.075. Well, remember, that's your R value, right? It's your rate. So before I can even answer that, I need to know what this is as a percent. So if I move that decimal 2 spots to the right, I get 7.5%. And since I know that this is an increasing percentage, I'm going to say that Sharon's account increases by 7.5% annually, or each year. Both mean the same thing. And then the last one wants to know what her balance will be after 8 years. All right, so let's make sure that X represents years. Sharon's saving account, it is annual interest, so we're good there. So what you're going to do is you're going to put 4,000 times 1 plus 0.075 to the 8 in your calculator to see how much money is going to be in Sharon's account. So 4,000 times 1 plus 0.075 to the 8th is $7,133.91. So $7,133.91 is now in Sharon's account. And that's it. That's how to work with exponential functions and to decide if something that you are given is exponential, linear, or neither.